in this video, we're going to be doing more of the same. We are given the zeros of a function, and we're asked to find the polynomial function that they came from. So here our given zeros are negative square root of 5, positive square root of 5, and 2. So let's turn these into the factors that they came from. So my first one, negative square root of 5, would have come from x plus the square root of 5. Positive square root of 5 would have come from x minus the square root of 5, and positive 2 would have come from x minus 2. You'll notice that we do have conjugate pairs in this one again because the first two factors are exactly the same except for the sign in the middle. So we want to multiply those together first because things are going to cancel out for us. So my first, x times x, gives me x squared. My outside, I've got x times negative square root of 5, which gives me negative x square root of 5. My inner is the opposite of that, positive x square root of 5. And then my last, positive square root of 5 times negative square root of 5 gives me negative square root of 25. Just like the i's on the previous video, these middle two terms cancel each other out. So I am left with the x squared. Now at the end, I've got minus the square root of 25, which is just saying minus 5. So that took care of multiplying the first two factors together. I still have this last one, x minus 2, and then I'll FOIL here. X squared times x gives me x to the third. X squared times negative 2 is negative 2x squared. My inner is negative 5x. And my last, negative 5 times negative 2 is positive 10. That one is completely done because not only are there no like terms, the exponents are already in descending order for us. All right, here's our next one. The zeros are negative 1/5, 0, and 4. So we're coming from three factors. If negative 1/5 is a 0, then it came from x plus 1/5. If 0 was your 0, it just came from the factor just an x. Then my last 0 is a 4, so it came from x minus 4. And then I'll multiply the three factors together. So multiplying these first two factors, I've got x times x, which will give me x squared. Then I've got x, or 1/5 times x, which gives me 1/5 x. So that took care of multiplying the first two together. So I'll bring down this last one, x minus 4, and multiply these. So my first, x times x, gives me x to the third. X times negative 4 gives me negative 4x squared. My inner gives me a positive 1/5 x squared. And then my last, I've got a positive times a negative, so I'm going to have a negative. I've got 1/5 x times 4. When you are multiplying these fractions, you just go straight across on the top and the bottom. So in the numerator, I'll have 4. The denominator, I have 5. So here, this last one that I just did over to the side, I've got 1/5 x times negative 4, which gave me negative 4/5 x. Now, I noticed that these middle two terms are like terms. So I've got to put my squareds together. I've got a negative 4x squared, and I need to add that to that positive 1/5 x squared. So since now we are adding fractions, I do have to have a common denominator. the common denominator between 1 and 5 is going to be 5. Which means I need to turn that first fraction, the negative 4 over 1, needs to have a denominator of 5. So I'm going to multiply the top and the bottom by 5, which will give me negative 20 over 5, and I'll add that to 1 over 5. So now they have the same denominator, so I'll just bring it over, and I have negative 20 plus 1 gives me negative 19. So that's how many x squareds you have when you combine them. So I have x to the third, and then my x squareds are negative 19 fifths x squared, and then bring down the minus 4 fifths x. All right, on the last problem of this video, we are going to be finding a function of degree 5. So this time it gave us 3 zeros, but the difference is it also gave us multiplicity numbers for each of these zeros. Remember, when we turn this 0 into a factor, the multiplicity number is the outside exponent of that factor. So, first one, if negative 3 is a 0, it came from x plus 3. If it has a multiplicity of 3, then that actually has an outside exponent of 3. Next 0. If 0 is the 0, remember, it just came from x. And since its multiplicity is 1, I don't need to see that exponent because x to the first power is still just x. On to the last one. If 3 is the 0, it came from x minus 3, and its multiplicity was also 1. So again, I don't need to multiply. I don't need to have that exponent. So what does all this say? X plus 3 to the third power means I need to multiply x plus 3 times itself and times itself again. And then I'll bring down the other factors of x and x minus 3. But for now, let's go ahead and multiply the x plus 3 times itself 3 times. So my first, x times x gives me x squared. Then my outside, x times 3 gives me 3x. My inside is another 3x, and then my last is plus 9. These terms in the middle are like terms, so you actually have 6 x's. So now I've got x squared plus 6x plus 9. So that took care of the first two x plus 3's. Now I've got to bring this last one down and got to distribute here. So the first thing I'm distributing is this x squared to both of these terms. So x squared times x gives me x to the third. X squared times 3 gives me plus 3x squared. Then I'll distribute the 6x to both of these. 6x times x gives me 6x squared. And then 6x times 3 gives me plus 18x. And then the 9 to both of those. So 9 times x gives me plus 9x. And 9 times 3 gives me plus 27. So now I need to clean this up a little bit because I have like terms. I can put those squares together, and I can also put these x's together. So I just have 1x cubed. My x squareds, when I put those together, I've got 3 and 6, so that gives me 9x squared. Then my x's, I've got 18x plus 9x, which gives me plus 27x. and then the constant of plus 27. So all we have done so far is that x plus 3 to the third. I still have the x and the x minus 3 factor. So if I'm multiplying this big parenthesis here times that x, I'm just going to distribute here. So now x to the third times x gives me x to the fourth. 9x squared times x gives me plus 9x to the third. 27x times x gives me plus 27x squared. And then the last one, 27 times x gives me plus 27x. So now I've taken care of this one and this one. I just need to bring down the very last one, which is the x minus 3, and multiply here. So x to the fourth goes to both of these. So x to the fourth times x gives me x to the fifth. X to the fourth times negative 3 gives me negative 3 x to the fourth. So I'm done with the x to the fourth. Now, moving on to the next one, which is the 9x cubed to both of those. So 9x cubed times x gives me plus 9x to the fourth. 9x cubed times negative 3 gives me negative 27x to the third. So now I'm done with the 9x to the third. I'll move to the next, which is the 27x squared times both of those. So 27x squared times x gives me plus 27x to the third. 27x squared times negative 3 gives me negative 81x squared. And then I'll move to the last one and distribute it. 27x times x gives me plus 27x squared, and 27x times negative 3 gives me negative 81x. And then I'll clean it up. Let's see. I only have that one x to the fifth. But I can put these x to the fourth together. I've got negative 3 plus 9, which gives me plus 6 x to the fourth. Then look at your cubes. You've got negative 27 and positive 27. So that's nice. Those just cancel each other out. My squareds, I've got negative 81 plus 27, so that gives me negative 54x squared, and then just bringing down the minus 81x.